Hi, my name is Lakshya Jain and this is my video for solution of maths end semester exam, question number 3. So let's commence. Right. So the question is that we need to find the motion of the mass spring system that is modeled by the ordinary differential equation y double dash plus 25y is equal to 24 sine t, and also given to us are the initial conditions that at 0 y is 1 and y derivative at 0 is 1. Another thing, we need to also sketch the graph of the solution curve, and y is equal to yp, that is the particular solution, right? So this I'm going to solve the following ODE using the method of undetermined coefficients. So I'm going to write it, method of undetermined coefficients. Right now, before that, we know that for any second order ordinary differential equation, linear ordinary differential equation, we have that its solution can be written basically as a superimposition of yh and yp, as the sum or superposition of two solutions that are yh, that is the solution of the corresponding homogeneous equation for the given non-homogeneous linear second order ODE, and the particular solution that we are going to find out using the method of undetermined coefficients. So let's start by first calculating the yh, that is the general solution for the corresponding homogeneous equation, for which in this case is y double dash plus 25y equal to 0. So let's compare this with the general linear second order linear ODE in the form of y double dash plus ay dash plus by equals 0. So on comparing, we get that a is 0 and b is 25. So in order to solve yh and find its solution, we need to first solve its characteristic or auxiliary equation, as it is called, which is of the form lambda square plus a lambda plus b equals 0. So let's substitute the values of a and b, which in substitution we get lambda square plus 0 plus 25 equals 0. So this gives us lambda square plus 25 is equal to 0, and implying that lambda is plus minus 5 iota. Now when the solution of this auxiliary or characteristic equation are a complex number, then the solutions of yh are of the form e raised to power minus ax by 2 plus I omega and e raised to the power minus ax by 2 minus I omega, where a is 0 and omega, let's calculate it. It's given by the formula half under root 4b minus a square. Let's substitute the values, that is under root 4b minus a square, 4 into 25 minus 0, this is half to 10, and this gives us 5. So there we have the omega as 5. Now on using Euler's formula and then adding, subtracting and multiplying with pseudo constants, we basically get that the solution of yh can be of yh is basically a superposition of two solutions y1 and y2, which are given by the form e raised to the power minus ax by 2 cos omega t and y2 as e raised to the power minus ax by 2 sine omega t. So on substitution, we basically get a is 0, so e raised to power 0, and anything raised to power 0 is 1. So and omega is 5, so basically y1 is cos 5t and y2 is e raised to power 0 1, and sine omega is 5 sine 5t. Right. So Now YH, as I said before and mentioned before, that is a superposition of both these two solutions, y1 and y1 and y2. So YH is given by AY1 plus BY2, where A and B are constants that belong to real number, right? So let's substitute the values. YH is, we get that YH is A cos 5t plus B sin 5t. There we have the solution of YH. Now let's get to the part where we need to find YP, and as I mentioned before, I'm going to use the method of undetermined coefficients. Now in this method, and by observing our RHS in this given non-homogeneous second order linear ODE, which is in its general form, right? The RHS is 24 sin t. So by observing, we get that the particular solution YP would be of some form C1 cos I'm gonna say theta t and plus C2 sin theta t, right? So where and the theta here would be the same as we have here, and since the coefficient of t here is 1, so theta in this case could also be 1. So basically we find that YP would be of the form C1 cos t plus C2 sin t. Right, now if I differentiate it with respect to time, then I'm gonna get minus C1 sin t plus C2 cos t, right? And if I differentiate it once again with respect to time, I get minus C1 cos t minus C2 sin t, which is basically minus 1 times YP. So y double dash p is equal to minus YP. Now this particular solution YP that we're going to find, this too is going to solve or satisfy a given non-homogeneous linear second order linear ODE. So we can substitute these values y double derivative p and yp into a given non-homogeneous equation, which was given to us as y double dash plus 25y equal 24 sin t. Right, so let's substitute the yp and y double derivative p. So basically when we do that, it would be of the form this: when y is equal to yp, so when y is equal to yp, y double derivative p plus 25 yp is equal to 24 sin t. So this is nothing but minus yp plus 25 yp is equal to 24 sin t. This implies 24 yp is 24 sin t, and this yields us yp as sin t. So if we compare with the form that we had written before, c1 cos t plus c2 sin t, we get that c1 is 0 and c2 is 1. So I'm going to write it here that c1 becomes 0 on comparing this with the above one equation of yp, and c2 is 1. So basically we get that yp is sin t. Now we're ready to write the general solution y. So y was solution y, which was a superposition of two solutions yh and yp, the particular solution and the general solution of the homogeneous corresponding homogeneous equation. On substituting the values, we get y as a cos 5t as b sin 5t plus sin t. This is our general solution. of a given non-homogeneous OD. Right, now we've been given the initial conditions that y at 0 at t is equal to 0 is 1 and y derivative at t is equal to 0 is also equal to 1. So we're gonna find the particular solution y by substituting the values. Now when t is equal to 0, then y0 becomes 1, and which becomes a cos 0 plus b sin 0 sin 0. Right, now a cos 0 gives us 1 and sin 0 gives us 0. So basically this gives us that a is 1. So our equation becomes that y is cos 5t plus b sin 5t plus sin t. Right, now let's derivate it with respect to t. So the first derivative gives us minus 5 sin 5t plus 5b sin cos 5t and plus cos t. Right, now at t is equal to 0, y derivative 0 becomes 1, and on substituting the value of t in this one, we get minus 5 sin 0 plus 5b cos 0 plus cos 0. Cos 0 gives us 1, sin 0 gives us 0. This implies 1 is equal to 5b plus 1. 1 and 1 gets cancelled and yields us b as 0. So finally our solution y becomes cos 5t as a is 1 plus b is 0, so this term gets eliminated, and sin t as it is. So our solution for the particular solution for the given non-homogeneous second order linear ODE is cos 5t plus sin t. Now let's plot the graph. Let's draw the graph for this particular solution. So basically this graph would be superposition of both these trigonometric functions, and the rough approximation for the same is what I'm going to be drawing. So this is a y, right? 1, 2, minus 1 and minus 2. So approximately this graph looks like something like this. This is a one cycle. The maximum value is 2. Yeah. This is a complete cycle that we have for this function, right? I'm going to draw another cycle, and it's going to look something like this. This is the peak value, sorry. And this gives us a second cycle. So this roller coaster kind of graph that we have here, this is a graph of the required graph of approximately required graph of our solution y. Now the points to be taken are that the maximum and minimum values, the amplitude of these of this graph is 2 and minus 2, and if we see approximately when we look at it, the if we look at upper bound and lower bound values, so this graph basically looks like a kind of a sine graph, has a structure of a sine graph. If we look from a broader view or a broader perspective, when we look at it when t tends to infinity and we see at the general trend, it looks as if it follows a sine graph with amplitude with the maximum value as 2 and some phase difference. So it kind of has that structure where it looks like the sine graph, right? So this is the required graph we have. Now the second another thing that we needed to have was we needed to plot the graph of y is equal to yp. Now if we are talking about yp, that we had the particular solution, it was sine t. So basically its graph that we have is a simple sine wave with the maximum value 1 and the minimum value -1. We have yp that keeps on increasing and ts. Another thing we could have was the graph of y minus yp, which corresponds to the graph of cos 5t, right? So plotting it under this t, we have y minus yp on the y scale, right? So this is a graph of cos 5t. If the maximum value we have 1 and minimum is -1, this graph acts like a normal cos graph, but its frequency is increased is by a factor of 5 as it contains 5 as the graph is of cos 5t. So as compared to a normal cos graph, it is comparatively squeezed and has a greater frequency greater frequency as compared to normal cos graph that we have, right? So these are the graphs that we need to plot. The graph of this particular solution that we found of the non-homogeneous ODE that we have, which is like this wavy graph that we found here, and we have for the graph of a sine t, the particular solution, and we have the graph for y minus yp, that is cos 5t.